Very good afternoon, guys. Today we are back with another problem. Today's particular problem statement is counting pairs with given sum. So say for example, we have an array, and before I go and solve this particular problem, make sure you guys like, share and subscribe to the channel. Okay, so this is the question. So we have an array of elements, say 1, 5, 7, -1 and 5, and our target value is, say for example, 6. The output we get is 3, but how we are getting the 3? So if I take any pair, then the sum has to be 6. So 5 plus 1 add up to become 6. 7 and -1 will add up to become 6, and 1 and 5 will add up to become 6. So total count of the pairs is 3. So this is what we are going to return. So now let us go and try to understand the algorithm. So first we will be using an hash map to keep the track of every element in the array, and for every element we have to calculate its complement target, which is -x. And if the complement target is already in the hash map, then the value of the key represent the number of valid pairs. Okay, so as you know, hash map will use a time complexity of O of n, and this will easily get the job done. Okay, so let us try to see and how this particular problem statement works. Okay, so let us first, I will just take a say, I can say a dummy array, so it will be easy for calculation. So if I take a dummy array as 1, 5, 7, -1 and 5, okay, and I will take my target to be as 6. Okay, I will take my target to be as 6. So if you see in this particular setting, what you guys can see is that I will have to take some values. Okay, so say column is value. Okay, and I can say this, my iteration will be also there, a count value, a complement value. Okay, and what else can I keep? Yeah, a count value, complement value, and a big hash map. So let me just think this to be an hash map ABC. So say for example, my value is 1 right now. Okay, so what will be my complement? Complement is nothing minus target minus of the present value, which becomes 5. So is 5 present anywhere over here? No, 5 is not present anywhere. So what we can quickly do is we can add this particular value to the hash map. So 1:1, frequency of 1. Okay, next value is 5. So we are going to calculate. So 6 minus 5, we will get a value of 1. Now you can see 1 is already there in the hash map. 1 is already there in the hash map. So we are going to add 5, okay, with 1, and my count will become 0 plus 1 equals to 1. Now come to the next value, which is 7. So if I have 7 over here, what I can see carefully is that I have to calculate the target. So 7 minus 6, sorry, 6 minus 7. So my bad. So I'll just make this as 6 minus 7. So I'll get a -1. So is -1 present anywhere? No, -1 is not present. So I will just put the value of 7 and put it as 1. Okay, now let us go to the next value, which is -1. So -1 is there. So complement will be nothing but 6 minus of -1, which is 7. So 7 is already present, right? So my count will become 1 plus 1 equals to 2. Okay, and the value -1 will be also added. -1 of 1 is also added. Now next value is 5. Okay, 5 is there. So 6 minus 5 is 1. Yes, 1 is already present in the hash map somewhere. Yes, at the start. So my count will become 2 plus 1. It will become 3, right? So I am getting a total count of 3, and this value of 5 will be also added. 5 is since present, so it will become 2. So my output will become 3. Okay, as I got from here. So it's a simple particular problem statement. Now let us just try to execute this problem which I have solved over here. So as you can see, we have taken a hash map of frequency, we have taken the count, we have initialized, we have iterated over a loop. Now we are using complement as target minus of num. We're checking whether it's present in the frequency table. Then we're increasing the count, and we are putting the current element to the map. Let us go and submit this particular solution. It works with O of big O of n time and space complexity. And make sure you guys like, share and subscribe to the channel. A lot of effort goes into making these videos, and we are looking forward to see you in our next video. Thank you.